Assalamu alaikum and good day. If you are looking for environmental tutorials, then you have found it. Welcome. Of course, I have my passion on motorbikes and shared them with you too. Well, environmentally speaking, I hope you found what you are looking for here. All the best and have fun. Assalamu alaikum and good day. Thank you YouTube subscribers and all viewers of my channel. Welcome to this video, and Parchi Khalid is back. This time we are inviting all environmental auditors and practitioners in this wonderful pollution control equipment called the Electrostatic Precipitator. As some of you may already be familiar with, the control technique is for managing air pollution. It is designed to trap air impurities or pollutant from being released into the atmosphere from their respective origin and sources. We are going to share how does it work and what to look for if we are interested to check its performance and compliance. So before we carry on, all my Muslim brothers and sisters, please turn off this video if you are already attending the Friday prayers or classes in the mosque. I wish us all Jannatul Naim. How does it work? First of all, let me remind everyone, safety first. And this ESP is not for our homes. There's intense ozone on the go. Having said that, let's continue. The ESP is an air purification system. It consists of wires and collection plates where high voltage is applied. So an electrostatic field is generated between those wires and collecting plates. Polluted air or gas streams then flows through. The plates are positively charged and grounded, as far as I know from my various audits. As polluted air enters, for example, emissions from, say, coal-fired power plant furnaces, these air pollutant dust particles were induced with negative charges caused by series of electrodes. Okay, so these negatively charged particles are being attracted to the positively charged plates. So cleaner air then passes through and being released out. Those particles which are being left behind are attracted and attached to the plates. These particles could then be released by turning off the voltage, but usually be aided by shaking, using rappers which knock those plates, or even washed away like in wet electrostatic precipitator or WESP. Those particles are collected in collection bins, hoppers if dry, or a collection sump of slurry when wet. From there, they are being managed accordingly, usually into the ash pond. This kind of explanation isn't meant for environmental engineers, but auditors in general. So let's move on to check what auditors should look for. So we have arrived at the sites now, imaginary, virtually. I expect that at this point, auditors have already done some good documentation review, and that areas that you wish to check arising from those documents are well sorted out and noted. Therefore, that would be one of your audit interests over here. It is important for auditors to identify performance indicators of the electrostatic precipitator too. We will see this shortly. In addition to that, I encourage auditors to utilize as much as you can your legendary eyeball engineering. In other words, sharp observation. As always, you may begin to check if all the specifications of this ESP which has been built and operate are identical to those which were detailed out in the design approval. Important criteria are, first, I would say the type of ESP, whether they are the plate wire dry ESP, or they could be the type which is flat plate, dry electrostatic precipitator, and the other type is the flat plate, wet electrostatic precipitator, and there is a two-stage electrostatic precipitator, and of course there is one more type, tubular collecting plate, or tubular ESP they call it, where what I usually notice is that the wet electrostatic precipitator has a higher voltage than the dry ESP. Correct me if I'm wrong. You may also like to justify if it is an integrated type of ESPs. Very interesting. I love this. For example, I believe you have heard of the SCR or WESP, which is SCR stand for Selective Catalytic Reduction Wet Electrostatic Precipitator. From my experience, this is a very good system whereby the SCR or Selective Catalytic Reduction was seen to be able to remove mercury, metals, dioxin, and even furans. The wet ESP alone is capable of removing particulates as small as submicrons, say 0.01 micrometer or microns, at more than 99% efficiency or effectiveness. Imagine that. This was based on a third-party report audit whose performance report on the WESP was made available when I came for a pre-ISO 14001 certification audit those days. In terms of efficiency indicator, I noticed that most experts prefer to check or use the correlationship between the ESP voltage, residence time or stay time, and inlet concentration. From my past experience, voltage is reported as kV or kilovolts. Residence time, do you call it stay time, reported in seconds, and inlet concentration in milligram per cubic meter. So auditors may like to verify on this by comparing its design specification, which was approved, versus what was built as displayed in the controller monitor display. As far as the efficiency of this ESP is, you may want to look also at some hard evidence, probably the ESP's performance. What I did was to check on their used collector plates. They brought me to their metal scrap yard where those degraded collection plates are stored. I saw mostly corroded plates, but that could be due to exposure to air during this storage. After all, this is a wet ESP. But I was observing some more prominent signs, permanent signs, such as beading or dry spots. My supervisor, who's an expert in ESP, once mentioned that beads or dry spots or stain spots, whatever you call it, over these collection plates is a sign that this section of the ESP is experiencing current flow inhibition. That simply means there are material buildup over the surface of the collection plates. Why? They are not thoroughly washed off. In other words, those particles were not washed away. Because water is not spread evenly, that's the way of putting it, and particles are not fully captured in this particular section of the ESP. So it wasn't washed away well and potentially resulted in increased emission from this particular segment or column. But in newer version of this red ESP is the membrane type. It is probably made of polypropylene, and flushing water is just being dripped, not sprayed, not even flushed. Less water actually. If this is the type of collecting plates that they are using, then you might not see any beading or dry spots on these used plates. For this case, the blow down liquid or flushing water, or some experts call them irrigating liquid, has very diluted amount of assets. So auditors, you may also like to verify on this. Was it part of the approved design or a modification upgrading has been done? Although it is a positive environmental endeavor, but when the legal thing kicks in, notification to the agencies must be made upfront. Please ask for a copy of that. Some consultants call this membrane WESP as having the wall-cooled collection electrode. Another factor of importance for auditors is to check on the flue gas velocity. There's another one. What I learned from experts who are well versed with wet ESP, this is related to the wet flue gas desulfurization or WFGD, commonly used in the coal-fired power plants. Some WFGD releases sulfuric acid mist into the wet ESP. Apparently, the capability of this membrane WESP corresponds directly to the voltage. There are special factors involved here, which is beyond my expertise, like plasma-induced effect, its relationship with gas velocity and voltage. I'm sorry, but what I have noted down very well and may help auditors here is to check their performance report if they have included performance parameters such as voltage, gas velocity, and sulfuric acid mist. Apparently, there's a relationship between voltage in kilovolts, flue gas velocity in meter per second, and sulfuric acid mist emission in milligram per cubic meter. There's a relationship. So this is about sulfuric acid aerosols being emitted out from the wet membrane ESP. So I believe that this is adequate for auditors on the go to comprehend and apprehend this interesting equipment. I decided not to talk about the bottom ash, fly ash, etc. and also the subsequent ash pond. Those would be covered in your audit scope or scheduled waste or hazardous waste and wastewater treatment compliances. By the way, since you are already here, please remember to verify the state of environmental health of their groundwater and adjacent rivers and water bodies within at least 3-kilometer radius from where you are on site now. I am sure you'll find some good reports on these items too. So all the best on the job. Have fun. Thanks for watching. I apologize for any shortage of information as I really want to make this tutorial short so that auditors on the go would find this nice and easy. I appreciate your attention. Please like, share, comment and subscribe if you are pleased with this effort. I wish everyone all the best in your life, and to all Muslims, Assalamu alaikum wa rahmatullahi wa barakatuh.